I have our agenda up on the screen for you, so if you could get your items out from yesterday, I would very much appreciate that. If you have a signed lab safety contract, I'll come and collect that from you, give you your grade for that. It's just the last page. You're going to keep the rest of the document. That'll be the first thing that goes in your physics folder or your physics binder. And then we're going to go over those 2 questions that I asked you to finish up on the front of our Unit 1 packet. So if you could get that out as well. And then we're going to start our first physics lab, which is a lab on measuring, learning, using the technique that we talked about yesterday, measuring correctly with a metric ruler and making multiple measurements and so forth. So that will be our first lab that we're going to get to. So let me come around and get the lab safety contract if it is signed from you. And that way later today, you'll see that in Aspen when you look, you just need the last name. Thank you. The rest you're going to keep in your binder or your physics folder. Thank you. No worries if it's not done. You do have until Monday to get that signed and returned to me. So on Monday, we want to make sure when I come around to collect it, that those of you who don't have it for today do have it for Monday for me. All right. So that is our first assignment, is to make sure that this is done for Monday, okay? The other thing I need you to do over the weekend is get your supplies that we talked about yesterday. Any questions about the supplies? The one thing you're going to need this weekend for your homework is the ruler. You will need a metric ruler to do this weekend's homework. So got to get your hands on one of those sooner rather than later. And the last assignment here. Okay, I will end it. The last assignment is going to be to make some measurements for a few objects that I'm going to give you to take home with you to make measurements of. Let me hand those out now, actually. Could you please take one of these and pass them down? Yes, take one and pass them down. Wait till everybody has one of these, and then I'll show you what I'd like you to do with them. And this will be your written assignment for the weekend. Keep the paper clip on there for now. Okay. Where's that other? Did everybody get one? No. There's no extra. You only took one? Who else needs one? Okay. Let me go over what you're going to do with this. You'll see here that your assignment this weekend is to make measurements in centimeters using the proper measuring technique and the correct precision. We talked about how to determine what precision you should be using based on the measuring tool that you have. You're going to use your own metric ruler to do this. And this is what I'm going to ask you to do. I'm going to put this on my document camera so you can see what it is I need you to do. Unfreeze the screen so that way we can all see it together. Okay. So we have here 4 different objects. You have this index card. You have this large square Post-it. You have a small rectangular Post-it, and you have this paper clip. Okay. On the back side, you're going to record your length measurements for those 4 objects in centimeters with correct precision. So you're going to need the length measurements. You're going to record them here. First, for the index card. You see that? You're going to tell me what the measurement is for the index card in centimeters. Then you're going to do it for the large Post-it. Then you're going to do it for the small Post-it. And then you're going to do it for the paper clip. And you're going to record them right there on the back. And they're all in centimeters. So you can add that to the end of the line where you're going to record them with the correct precision. All right. Now, let's just review what I mean by length. Especially when you look at this index card. You should see that one side is longer than the other. The length refers to the long edge. So I want you to measure the length from here to here in centimeters, the long edge. When you do that, for this Post-it, this is a square, so it's not going to matter which edge you measure. This edge and this edge should be the same length because it's a square. This one's a rectangle, so it will matter which edge you measure. Which one are we going to want to measure? The long one for the length. For your paper clip, you want to measure from here to here. That's the length of it. You follow what I'm saying? That's your homework for the weekend. Should be pretty easy to do, right? Okay. So please put this away. You're not going to be working on this in class unless we have time at the end of class to do this. All right. What we're going to do now, let's see, where am I? We need to go over problems 2 and 3 on page 1 of our Unit 1 packet that we were looking at yesterday. So could you please get that out? By the way, I read through all of your student information sheets. It was very interesting. Some of you did some really cool things over the summer. I'm quite impressed. A lot of you went to Disney. My goodness. That's a big trip. It's an expensive trip. I'm glad you had that opportunity. Or did some sporting events. And I know a lot of you are nervous about the math in this class. I want to reassure you that I'm going to help you through the math. Okay? Math may be hard for you, but by the end, it's going to be a lot easier because we're going to do a lot of practice, and I'm going to help you through it. So I'm trying to alleviate some of that anxiety you indicated you have, and so that way you don't feel quite as nervous about finishing out this class with me. I just need a blank piece of paper here. All right. So we did number 1. Let's look at number 2. Back to my other screen. There we go. This is my answer key. Anybody want to tell me what they said the length of that little bar was? What'd you write down? Any volunteers? Yes. I agree with that. That's exactly what I had, 0.41 meters. Now, in terms of tolerance, because we're all measuring, we all should have had the 4. This 1 could have been different. Okay, so you could have had anything between, we actually give you plus or minus 0.02. So anything between 0.39 and 0.43 meters would have been accepted. All right. We want to make sure it did go to the hundredths place. That's really the key. The hundredths place was the digit that you had to estimate. And I think we can all see that it went to the fourth line, 1, 2, 3, 4, some of you might have said 0.40, thought it was right on that line, and that's okay. That's within the tolerance. Now, why are we measuring to the hundredths place and not the tenths place or the thousandths place? Can anybody tell me why that is the case? What'd you write as your rationale for why you're making the measurement to the hundredths place? Yes.
And subdivisions.
Yeah, so these subdivisions are the tenths place, which means you have to estimate one more decimal place, which is the hundredths place. How many of you got number 2 correct? Fabulous. Please give yourself a star. I'm a big proponent of giving yourself a pat on the back when you do things well and correctly. Feel good moment. You understood it. All right. How about number 3? Yep. Perfect. I said it was 0.5 meters. Now we're going to give you plus or minus 0.2 on this. So if you said 0.4, 0.5, or 0.6 meters, you're okay. It would not be accepted if you said 0.50 meters. That is the wrong precision. Can anybody tell me why we're only measuring to the tenths place here? Yes. Yeah, the subdivisions are actually just the ones place. You have a 0 meter and a 1 meter down here. Those subdivisions are to the ones place. So the estimated digit goes one more decimal place, which is the tenths place. And that's where you have to stop your measurement. Very good. How many of you got this one correct? Excellent. Give yourself a star again if you got it. Okay, let's put the packet away. We don't need it anymore today. We're now going to start our very first physics lab. As I try to keep myself organized here. I got way too much stuff. And it's only day 2. Makes me a little nervous, but I've got so much in front of me and I'm already misplacing things. Okay, put this all over here. Let me give each of you a lab worksheet, and then I'll tell you what we're going to do with this lab. Just a pencil for this, no pen. Remember, the only time you're going to use a pen in this class is when? Do you remember? When's the only time we use a pen? Tests, right. This is not a test. This is a lab. If you need a pencil, they're up front in that green tin. You never have to ask. Just go up and help yourself. And you can keep the pencil. We have lots and lots and lots of pencils in our physics office. I'm happy to supply you with a pencil if you ever need. Pens are another story. That was here? Oh, I'll take it. Yeah. This is it. Yeah. You already did. Okay. You were not. Very good. Thank you, though. And is this your paper clip? I think this was here as well. Yeah. All right. I'll take it. I think the previous class was doing something with the paper clips. And I just got left behind. All right. Let me explain to you what we're going to do with this lab. First thing I would like you to do on the top, you see it asks for your name. Go ahead and please put your name there if you don't mind. I'm going to do it on mine. Okay, so put your name there. This is going to be my lab sheet, and I'm going to walk you through what we're doing. You'll see in this lab that we have 2 data tables. The top table is titled length. The bottom table is titled width. We're going to be making 4 measurements for the length and the width of something. Very similar to what you're going to be doing for homework, right? For your homework, you're going to make 4 length measurements using correct precision. You're going to do that here too. Now, what is it that I'm going to ask you to measure the length and width of? It's this piece of paper. I want to know what is the length and what is the width of this piece of paper. Now, you're going to do it, as you can see, in centimeters. Do you see how the column headings here have units after these labels? That means you do not have to record centimeters after every number that you write. This is a way to abbreviate things. We put units in our column headings to save us from having to write units after every number. It's a shorthand way of doing things. In physics, we like to find a lot of shorthand ways to do things. Less writing. This is not like English class where you're being tasked with writing 1,000 words. Oh my gosh, if you are ever asked to write 1,000 words in this class, I'm quitting my job. Okay, I am about short and sweet, and let's keep this simple. All right, so no units on any numbers. They're already at the top in our column headings. You'll then see that we will calculate some averages, but we'll do that later. Here's what we're going to do. You're going to be broken up into groups. There are 24 of you. We're going to break up into 6 groups of 4. 1, 2, 3, 4. This stands for the group member number. Each of you in your group will be assigned a number. So if you're in a group of 4, one student is going to make measurement 1. The next student will make measurement 2. The next student will make measurement 3. The next student will make measurement 4. You figure out, keep it consistent in the group. So you're not just randomly writing the 4 measurements down. Yours is always that row. You're going to be making one measurement for the length, one for the width, and then you're going to share your numbers with the rest of the group. So it's not quite so repetitive. All right. Here's what we're going to do. If you recall yesterday, when we were looking at measuring the length of something, we said we don't start at 0. Do you remember why that is? Why don't we start with 0 on one of these meter sticks? Yeah, it's probably worn down. As you can see here, there's no 0. You can't start at 0. There's no 0, which means we have to do the same thing we were doing yesterday with making a measurement with the right side and the left side and then subtracting. Remember doing that to get our length of something yesterday? That's what we're going to do here as well. So let me demonstrate what you're going to do. First of all, if I were to put the meter stick like this, am I measuring the length or the width of this paper? The width. Okay. So your width measurements are going to go in table 2. So to make your length measurement, you can turn the paper this way, set your meter stick down, and I'm going to make a suggestion that you start the left side at an exact whole number. Set that up. So I'm going to start this at, let's say, 3.00 centimeters. Now, right now, that is at exactly 3. But when you look at the screen, does it look like the left edge is on 3? Okay, let me tell you why that is. Have you ever noticed if you're sitting in the passenger seat of a car and you look over at the driver's speedometer and there's a needle? Not a digital speedometer, one of these analog ones, that you're not reading the same value as the driver's going to read. Have you ever noticed that? That's what's happening here. It's a type of error called parallax error. And when we make measurements with our ruler, we want to avoid that error. Scientists are really into this. You have to make sure that you are looking straight down at something. You can't look off to the side to make the measurement. It's not going to be correct. So this camera, which is here, is not over the left edge of the paper. So it's not going to give us a correct value. So in order to do that, I would have to move the camera so its lens is right over that left edge. And can you see now how, as I move it to the left, so it's over, it's now lined up exactly at 3? You see how that changes things? That's something that we're going to learn about later when we study light. It's an optical illusion type of thing. It's called a parallax error. So when you make the measurements with the meter stick yourself, I need you to make sure that your eyes are straight over that side of the meter stick. Okay, can you do that for me when you do it? Thank you. And then you're going to do the same thing on the right side. So I know my left edge for me right now is at 3 centimeters, but the precision of this meter stick, if I look, do you see how the small subdivisions, what are these subdivisions in terms of centimeters? What decimal place are these lines? Tenths. So what decimal place do I need to write the value down to? The hundredths, right? One more. So this left edge would be 3.00 centimeters. Now I'm going to do the same thing on the right edge. And of course, I just moved it, which I didn't want to do. So instead of, I'm going to go to the right edge, see if I can get the camera lined right up over that. Not quite, because whoops, this is trickier than it looks because of this camera. Let's see, I'll go something like this. This edge, I would say, is at 30, 5, 6, 7, 8, 9. So maybe 30.82 centimeters. So here's what I would do if this were my measurement. Let's say I was group member number 1, and this was my length measurement. I am number 1 in my group. So the right side, which is the bigger number, I just said was what, 31.82. The left was 3.00. What I'm going to do is subtract those numbers to give me the actual length. And when I subtract, I have to keep the precision. I'm going to keep this up on the screen when you're doing it. This is not what you're going to write down because I am not in your group. You're going to have 4 student measurements. This is just an example of what you will do. 31.82 minus 3.00 is 0.82. 11 minus 3 is 8. So that's 28.82. You're going to do one of those, and then you're going to do one for the width, the same thing. This is the bigger number, and this is the smaller number. When you're reading your ruler, okay, the right number is always the bigger number, but it goes in the left column. So please don't let that confuse you. You're going to make one, and you're going to make one for width, and then you're going to share your data with the other members of your group. Okay? Understand what you're going to do? So let me break you up into groups. You're going to be in groups of 4, and each group of 4 is going to be given 2 meter sticks. Here's what you can do. Because the meter stick is so long, it's almost the length of your lab desk. You can both be making a measurement at the same time. One person using this end of the meter stick, another person using this end of the meter stick. You follow? Okay. So you can both start with the length, both start with the width. I'm going to say you are the first group of 4. You remember 1, 2, 3, 4. Put a little star next to your number. So 1, 2, 3, 4. You are a group. You remember 1, 2, 3, 4. You're a group of 4. Number 1, 2, 3, 4. 1, 2, 3, 4.
So pretty much we're getting we're getting 2 measurements because
1, 2, 3, 4. You're a group.
So you're going to
your
do the
number,
bigger
1,
number
2,
here
3,
and
4.
smaller number.
And then you're a group
Subtract
of 4.
This is
1,
total.
2, 3, 4. Okay, let me get you some meter sticks to work with. And if you're not sure, call me over to help, and you can also talk to your group members.
60, and then much easier, like in the middle.
I have to go get some more of these. There's a meter stick for the 2 of you to use. There is one for the 2 of you to use. I gotta get 1, 2, 3, 4 more. Just make sure you're putting your measurements in a correct table.
My bad.
You're welcome. You're welcome. You can start with the length or the width. Just make sure it goes in the correct table. 2 of you. And 1 for the 2 of you. You're welcome. Let me know if you get stuck. And I'll be glad to come over and help. If you have a calculator with you and you'd like to use it to do your subtraction, feel free to pull it out. Otherwise, I think you can probably do it in your head. Just make sure you keep the decimal place out to the hundredths. I'm going to make one for my width as well. And we should be getting numbers that are pretty similar to each other overall. Your length should be about this. After you do your subtraction with the correct precision. And then your width should be about that number as well. It may not be exact, and that's okay, but you shouldn't be getting a width of 27 point something centimeters. That's way too far off. And your length should be somewhere around 28 centimeters. Between 27 and 29. And this should be between like 20 and 22. Once you have your numbers, share them with the members of your group. So that way both data tables, all 4 rows, are completed. Yes, you can talk to each other. Absolutely. Talk to each other to get your numbers. So where's your other numbers? Oh, they're compared. I gotcha. Yeah. You're starting at 70? Okay, so your left value is 70.00. That's when you're showing. So that's okay. Okay, here, one more decimal place. That means you're saying 7 and 9. Unless you're right on it. You're right on it.
Yeah.
Okay, so never make that. Yeah, did you say 97 point? What's the 70? 97.7. This minus this would give you 27. Just have you then. About 70?
Yeah.
We can add
Yeah.
How we doing? You doing okay? Now, if you need a calculator today to get our averages, I do have some that I can loan out for class today. Raise your hand and I'll come get you a calculator if you need one so we can do our averages. Because you're each going to calculate an average and then compare it with your partners. Make sure you're doing the math right. Anyone else need a calculator? If you have one, pull it out, because we're gonna be doing that average calculation in a minute. So, like I said, the first one, the length should be somewhere between 27 and 29. And then your width should be somewhere between 20 and 22. Yeah, so this one's off too much. Okay, so we want to redo that one. Actually, no, your math is wrong. 91.52 minus 70.00 would be 21.52. So you're in the correct one. They should be similar. If they're very different, then whoever made that measurement should go back and check it. Maybe there's a math mistake, or maybe you read the numbers wrong. Which one? This one? Those are all pretty close. That's okay. Yeah, those are all fairly close. Anyone else need a calculator? Okay. When your group has finished making all your measurements, can you raise your hand? I will come and collect your meter stick from you because you won't need it anymore. The two of you are done with this one? When you're done, I will just raise your hand. I'll come take it. Thank you. Thank you. You don't need that one either? You're both done? Okay. And then we'll review how to make an average measurement using proper scientific technique. Are you done with your meter stick? Okay. Are you done with your meter stick? You both made your measurements? Okay. Are you both done with your measurements? Yes. All right, let's talk about how to do the averages. I'm just going to make up some numbers to populate my table, okay? Actually, no, I'm not going to make them up. I'm going to pull out Students Lab from last year. It's there. All right, let me populate my two tables with some data that was collected by other students previously. Okay, let me show you what you're going to do to get your average. You all have your calculators? You're going to need it. As I just said, pull it out. You're not going to rely on your partners to do this, because if one of your partners makes a mistake who's doing it, now you are losing credit for their mistake. All right, this is why I want each of you to do this with me. What I'd like you to do first, let's start with the length table. Please add up your 4 lengths. Add them up. Add them up. Add up your 4 numbers. So this is my sum of these 4 lengths. Now that's not the average, right? What do you do with that sum to get the average? Now I'm going to divide it by 4, just like I'd like you to as well. Your average must be rounded to the same precision as the numbers here. So my calculator gave me an average that worked out perfectly to the hundredths place like it needed to. But is that always going to happen? No. You need to understand that when you do an average, the average is always rounded to the same precision as the data in the table. Since all of the data is going to the hundredths place, you round your calculator answer to the, round it to what place? Hundredths place, because all the data went to the hundredths place. You follow what I'm saying? Can you do that now for your width? Figure out what your average width is. Is it going to match mine? No, I don't have the same data that you have. See, is that to the correct precision? No, I have to do some rounding with my width, don't I? What? Can you see my calculator answer? Can you tell me what my average that I'm going to write down should be? What am I going to write down for my average width? 21.56 is correct. The digit that I need to round to, the place, is right here at the hundredths. I look at the next digit to determine whether that 6 will round up to a 7. Since that's a 2, we don't round it up. The rule for rounding up is 5 or greater. So if this said 21.565 something, I would round it up to 21.57. But my average is 21.56. And that's it. All right. Please check that the average you wrote down for your length and the average you wrote down for your width matches your partners, because you should all have the same average length and average width because you had the same data. Oh, because you're in scientific notation. There you go. There you go. That's your sum. But that's not the sum of 4. That's the sum of what, 2?
Yeah.
You and your partners agree on the averages? I hope so. That's something I'm going to be checking when I grade your lab, is that your numbers all match your partners, that you copy things down correctly and do the math correctly. That is it for our first lab right now. It's not done. We can't do any of the questions yet because we haven't learned the scientific process to do the other questions. So please just put that in your physics folder or your physics binder. Any questions on what we did today? All right, so let's just review again what you're going to do for homework. And hopefully you have this jotted down somewhere to remind you of what you're going to do. Those of you who have not gotten the lab safety contract signed, please make sure you go over that with a parent or guardian at home, somebody at home who's responsible for you this weekend. Get it signed, and on Monday I'll ask you for it. Then get all your supplies. The most important 2 supplies you need right now are the calculator and the ruler. The ruler so you can do the homework. And what is the homework? It's to make those 4 length measurements in centimeters and to record them on the back of the index card. What I will be doing on Monday, to just give you a heads up, on Monday, when you get to class, once everybody is seated and you're getting your things out, I'm going to be coming around to check that you actually made those 4 measurements. If you did not make those 4 measurements, not are they correct, but did you actually attempt to do the homework and make the 4 assignments or 4 measurements? If you did it, you're going to have your CCR, College and Career Readiness grade of a 1 for the day. If it's not done, you automatically get a 0 because you did not do the homework that you were assigned. You follow what I'm saying? Should not be a difficult task. If you need help getting a ruler over the weekend, you can, and you're not able to accomplish that, you can stop down here during homeroom, before homeroom on Monday. Okay? Have a great weekend, everyone. Thank you.
We're measuring the long side of the index card.
Yes, everything is the long edge. You're welcome. You too.